All right, so an electrical engineering application that I wanted to take a look into today is a flashlight, and more specifically, the LED light inside the little square. LED stands for light emitting diode, so that's a topic that was covered in this course that I wanted to take a look into. First, I'm going to go over a quick circuit diagram of what is inside a flashlight. This is the LED driver circuit, which is partly responsible for how much power goes to the light. So we have a voltage source, capacitor, resistor, inductor, and then we have a transistor here and an LED. The transistor is partly responsible for the brightness of the light. This can amplify the current, which then amplifies the brightness of the flashlight. So this here, oh, let me start sharing. So in my hand here, this is a brighter setting of a flashlight. I can change it to something that's dimmer. This is partly through the transistor. The LED light emitting diode aspect of the light or of the flashlight is what, as it says, emits the light. It does this by releasing energy when current passes through. So let's take a further look into how this works. So we have a semiconductor here with a PN junction. So you have the N region, P region, the depletion region, and then on this axis you have energy with the valence band and conduction band. So as a recap, when this depletion region, or I should say when the semiconductor or diode is in reverse bias, this region here, this depletion region widens and it stops electrons from being able to flow from the N region to the P region. And this is what makes a diode be off. Oppositely, if it's in forward bias, the electrons can flow from the N region to the P region, allowing current to flow through it and act as a diode. So how does light get produced from something like this? Well, as the electrons flow, as I showed, from the end of the P region, a few of them will fall from the conduction band to the valence band. As the electrons fall, they will cross this white gap here, which is an energy gap called the band gap. When the electrons fall from the convalent or from the conduction band to the valence band, they cross the band gap. As they cross the band gap, they release energy. This energy is released as light. Something cool about this is that the band gap is what is responsible for the color of the LED light. So a small band gap requires a low energy release, and this would correlate to a red light or yellow light that doesn't have a lot of energy. On the other hand, if this band gap is very big, the energy release will be high, and this will correlate to blue or purple light. In a flashlight, though, the LEDs have a cover on top, which make it white. So most flashlights have white light instead of a certain color, but still kind of cool. Another cool fun fact that I found through this project was that it took decades longer to create blue LED light as it did red or green LED light, just because creating a semiconductor that allowed electrons to fall at such a large band gap was pretty difficult. All right.